Area of a non-right angle triangle, NRAT derivation. I've got a non-right angle triangle here. What that meant is none of the angle is equal to 90 degrees. So for this angle capital A, and that's capital C, and that's capital B, so that'll be A, C, B. The side to this angle is little a, opposite to A, and opposite to C will be little c, and opposite to B will be little b. Now to find the area of a non-right angle triangle, the area of a triangle is basically a half base times height. So I need to find the height here if I can. And that height this is now a right angle there, so that height is h. And the area for that will be area equals a half. Now, in this case, a half of C, because this side is C, so a half of C times H. What I then need to do is to try and eliminate H. So I need to find another way to eliminate H because I don't know what H is. So to find that, I need to find sine of B or sine of C or sine of A. I could choose any one I prefer. In this case, I have to choose A and B. So I'm going to use sine of B here. Sine of B equals sine. I'm using something called car to R. So implies this is sine. Sine of an angle theta in this case will be opposite over hypotenuse. And in this case, the a half is there. So sine is opposite, sine is opposite in this case, which is the opposite of B is H over the hypotenuse is A. So that will be H over A. And now I need to make H the subject. So H will become, multiply both sides by A sine B. So that's what H is. Now I need to replace H here with this value because that's what H is. So the area would then become a half. Well, A comes before C, so I'll write A first alphabetically. I have AC sine B. Now you can see the letters. You always have the three letters involved in the area of the definition. And also the angle always involves the two sides to the angle. So you can see B has A and C. Those are the two sides to the angle B. So to work out the area using angle A is going to be, area will be, look at the angles, the two sides to A. So it's going to be a half BC, because C and B are sine A. If you're going to do it for C, you have to do area equals a half AB sine C. So that's how you work out the area of a non-right angle triangle. Right, there are two other conditions to consider. We need to look at the area of an isosceles triangle. So if you have isosceles triangle, that means equal sides. In this case, because the sides are two equal sides, so let's call that R, and that's R. And this angle here is, let's call it theta. The area of this isosceles triangle is going to be, because the two sides are equal, it's going to be a half. It's exactly the same thing. The two sides, R times R, sine of the angle that contain them. So theta. And we can write that as a half R squared sine theta. And that's for how you find the area of isosceles triangle. Now, if you're to find the area of a sector, so that's the other one we need to look at. So if you look at a sector, area of a sector. Now, a sector, first of all, if you got, this is a circle. A circle, the area of a circle is pi r squared. And the area of a sector, so if you take a sector, it's like a pizza when you take a sector of a pizza. So we got the center of the circle here, and you got the radius there, and here's a sector. So this one is a minor sector. So that is a minor sector, because it's a smaller one. The rest of the circle is a major sector. And this sector has an angle which we call theta. That means the side here is the radius, and that's the radius. The angle of a circle is 360 degrees, which we call 2 pi. Now, so the way to work out the area of a sector is to compare the area of the circle to sector. So this one has an angle of theta. This one has an angle of 2 pi. So the area of a circle, right, divided by the angle of a circle, so that's the angle, should be equal to the area of a sector divided by the angle of a angle of circle sector. So that's what we're doing. So what's the area of this circle? That's pi r squared divided by 2 pi, you can see. And that should be equal to the area of the sector, which is what we're looking for, divided by the angle of a sector, which is theta. Now, what we need to do now is to write down the area of the sector. So you can see the pi cancels out, and then multiply both sides by theta. So if I times that by theta, I have to times that by theta, and that meant theta cancels theta. I'm left with the area of the sector. So the area of a sector here will be equal to 1/2 r squared theta. And that's how you derive the area of a sector. Right, so now you know the 3 important parts when you're working out the area of a triangle, area of the sector. Now, the most important thing here is a segment. Because if you look at a segment, when you have a circle and you split it into 2 like that, you form a segment. Minor segment, major segment. It's just similar to sector, but the sector is coming from the center. Right, so minor segment, major segment. So let's draw a circle here. And this circle will have, that's a circle. And this circle from the center, here, I have done that and that, so that's the radius. And so I form a sector. But then if I draw a line here, that's a segment. You could be asked to find the area of a segment. The best thing to do is to use these two, because that's isosceles triangle formed from the sector. So the area of the segment here, segment, will be equal to, well, you can see the area of the sector is bigger than the area of the triangle. So you say area of the sector, which is 1/2 r squared theta. So that's the area of the sector. We just work out the area of the sector. Take away the area of the triangle, which is a half r squared sine theta. So the area of the segment will be a half r squared is common, and take away theta from sine theta, and that's the area of the segment. So this little bit here is a segment. And that's one of the uses in that case of working out the area from triangle, non-right angle triangle, to isosceles triangle, to the sector within a circle and a segment.